Hello. In this video, we will talk about the elementary row operations which are used to solve the system of linear equations. There are three fundamental row operations. So, the basic three row operations are here. The first one is swap, the other one is scaling, the third one is, you can call it addition, right? Addition. So what is meant by swap of rows? That means if you have two rows, for example, the first row is Ri and the second row is Rj, you can change their positions. For example, you can transfer row j here and row I here. You can change their positions. So I will denote by double arrow. Double arrow means Rj will take the position of Ri and Ri will take the position of Rj. Okay, what is meant by scaling? By scaling we mean that we can multiply any row by any scalar. For example, if Ri is any row, we can multiply with any non-zero number. Then that means Ri can be replaced by any non-zero k times Ri. I mean, you can multiply the whole row Ri with some non-zero constant k. But here k must be non-zero. This is very important. Okay? You can multiply any row with any non-zero constant. So this is called scaling. Okay. What is meant by the addition or linear combination? So if you have two rows Ri and Rj, then you can add them but as a linear combination. How? You can do Ri plus some scalar k times Rj. This is called addition as a linear combination. So you can do these three operations, and using these three operations we can convert our given matrix into the echelon or the row reduced echelon form. Okay, let's do an example here. Suppose this is an example and you can check this is row 1, you can check this is row 2, and this is row 3. Okay, when I talk Ri and Rj, that means Ri means R1, R2 or R3. Okay, any of these rows if the matrix is 3 by 3. Similarly, when I talk about Rj also means any of these rows. Any of these rows. Okay. Okay. So the first method is the first operation is row swap. I mean, if you have this system or this matrix, you can swap any two rows. If you want to swap R1 with R2, you can do that. If you want to swap R1 with R3, you can do that. For example, how can I swap R1 with R3? This way. I will write R3 up. What is R3? R3 is this, 301. I will write 301 up and then R1 down. R1 is 213. I will write 213. And this thing will be the same, 451. So what I have done here, I have swapped R1 and R3. R1 is swapped by R3. So you could have swapped R1 with R2 or R2 with R3. Or you can do any kind of operations, right? Any kind of swapping is possible. So I have given you an example of the swap of R1 with R3. Okay. When you are swapping R1 and R3, in that case, R2 will be fixed. It will remain the same. There will be no change. And similarly, by scaling we mean you have any row, you can multiply that row with any scalar. Okay. What is meant by scaling? Scaling is, suppose you want to multiply any row with any scalar. You can choose any row. For example, I am choosing this, this is my latest matrix. Suppose I am choosing this row. You could have chosen this row. You could have chosen this row, but I am choosing this row. And I want to rescale it. I want to scale this row. Okay. So in the scaling, I have to choose Ri. I have to choose any row. And then I have to find the non-zero constant. So I have chosen this row. And I want to choose a non-zero constant. The non-zero constant is, let k is equal to 1 by 2. And this k can be multiplied this last row to rescale it. So when I am going to rescale the last row, my first two rows will be the same. Okay, what will happen then? 3, 0, 1, 4, 5, 1. So 3, 0, 1, 4, 5, 1. And what I have to do, I have to rescale R3. What to do? I have to multiply R3 by 1 by 2. So I will write 1 by 2 times 2, 1 by 2 times 1, and 1 by 2 times 3. Okay? 1 by 2 times 3. And this is equal to 3, 0, 1, 4, 5, 1, 1, 1 by 2, 3 by 2. So this is called scaling. Similarly, you can do any kind of scaling. I have done the scaling with this row. You could have done with any row and by any scalar, any non-zero scalar k. Okay. And the last operation is the linear combination. What does that mean? That means if you choose any row, any two rows, for example, this row and this row, then you can do R1 plus, for example, 5 times R2. You can do that if you want. Similarly, you can do R1 plus 3 times R3. You can also do this combination. You can choose any kind of combination and you can replace it with any row. We will do these kind of problems, these kind of operations in the next upcoming examples. So let's do an example properly. So let's do a very simple example. We have the system of equation and we have to solve it. Okay. So first of all, I will write the augmented or extended matrix. I will write augmented matrix is, so in order to write augmented matrix, I will write A line and B, A and B. So A is the coefficient matrix. So what are the coefficients of x and y? Here the coefficient of x is -2, the coefficient of y is 5. Here the coefficient of x is 1, you can check. Here the coefficient of y is -1. So I will write -2, 5, 1, -1. 1, -1. And then I will write the constant. The constants are 4 and 1. Okay? So this is the augmented matrix. So in order to solve such systems, we have to make here 1. Okay? So we have, so how can we make here 1? I have to think about row operations. I have 3 kind of operations. The, the first operation was swapping. The second operation was scaling. The other operation was adding. So now I can swap these 2 rows. If I swap these 2 rows, this one will go to the top position and this -2 will go here. So my aim is to make here 1. Okay. In these kind of questions, I will make here 1 and then everything below 0. And then I will make here 1 and everything up and down 0. Okay. So this is my aim. So what to do? I have to make here 1 first. In order to make here 1, I will swap R1 with R2. Swap R1 with R2. So what will happen then? 1 minus 1, 1. Minus 2, 5, 4. Okay. So now I have to make here 0. The next target is make here 0. How can I make here 0? You can check. I have to use this row to make here 0. You can check here I have 1 and here I have -2. Okay? So what to do? -2 I will write. So I will write -2 plus some number times this value 1. I should get 0 because here I need 0. Okay? I should get 0. Here is -2. Here what should I put? If you think, if I put here 2, then I will get -2 plus 2 times 1 is 2, which is 0. So that means this number should be 2. Okay? The missing number should be 2. Here I will write 2. So this -2 will correspond to R2 plus this 2 will correspond to the scalar 2 and this one will correspond to this R1. Okay, so this is the operation which I have to perform to make this number 0. Okay, so I will perform this operation here. Okay, so if I perform this operation, I will get this matrix. Okay, you can check. So the operation is R2. So here is R2, -2, 5 and 4. Because you can check -2, 5 and 4 is R2. I have written R2 first. And then I had to write R2 plus 2. So I have written +2 everywhere. +2, +2, +2. I have written down +2 everywhere. And then 2 times R1. R1 is 1 minus 1, 1. You can check this is 1. This is -1 and this is 1. So that means I have performed the operations correctly. If I solve it, this is 1 and this becomes 0. This is -1 and this is 3. This is 1 and this is 6. Now our next target is to make here 1. Here I can make 1 by dividing the last row by 3. So what to do? I have to divide the last row by 3. So what I have done, I have divided by 3 the last row. So after division, I will get 0, 1 and 2. Now I can easily find the values of x and y from the last row. You can check this variable corresponds to x and this variable corresponds to y. So from the last row, from R2, I can check 0 times x plus 1 times y is 2, which means y is equal to 2. And similarly, R1 corresponds to 1 times x minus 1 times y is equal to 1. This means x minus y is 1. If I put y is equal to 2 here, this means x minus 2 is 1. And if I take this 2 to this side, it will be 1 plus 2 and x is equal to 3 then.